write which numbers do you want to see. Do you go overhead questions about 1 and 5, 1 and 3, 2 and 3, 1, 2 and 4, 1 and 4, 1. I think we got a mixture of all of them just then, so we can go through them all. 1 through 4 can be done on Desmos, so we'll go through those first. So for number 1, it says calculate the line of best fit. So you would have needed to add in a table, put in your points from the table, and then type in y1 tilde the squiggly line mx1 plus d, and it would have given you these decimals. You can round to 1 or 2 decimal places or use all of the decimals, but your equation for number 1 should have been y equals, if you're rounding, 0.9x minus 0.1 or 0.89x minus 0.09, or you could use all the decimals. So you'll need to remember these steps. How do you get the table? How do you get this equation? Because that will not be given to you on the SLL nature. So how did I find them? How did I round it? So you choose 1 or 2, doesn't matter. Or don't round at all, either or. So negative 0.1 or negative 0.29, either or. Other questions on that one? So how you round is up to you. I'll have all different answers when I go to check it. The second question is saying, using number 1, find the milk consumption in 1 week of a 7-member family. So your number of family members is x. If you put in x equals 7, find where those two cross. 6.153 or 6.15 or 6.2, any of those gallons. Make sure you label it. Questions on 1 or 2? Y equals, and then uses. Number 3, if the construction company charges 15 per hour, because it says per, that number is going to go with whatever your variable is. And then it says plus a one-time fee for the use of a trash dumpster for 60. So you're going to be adding 60 to that. And then we're looking for the number of hours if the final bill was 195. So equal 195, and then you could set up this equation. 15x plus 60 equals 195. See where that crosses the x-axis. 9 hours would be your answer to number 3. You can use Desmos for all of your word problems if you know how to set it up. 2 was 6 point something. So make sure you put the label on 3 as well. 9 hours. Questions on that one? Number 4, because it says write an equation, I've been telling you when you see write an equation, type in your y equals mx plus b. However, because I already have a table in here and this, it's going to go with whatever that is. So when you are playing with this or on your SOL, if you already have a table in there and you've already done line of best fit stuff, you'll have to delete that stuff before you could do this, otherwise the sliders won't work. Or exit it and come back to it. Because now the sliders are there. Now that I have a new graph, I just hit play on this. That's why it's moving on its own. It said parallel to the given equation. So I put in this equation. I put in this point. It's parallel, so it has to have the same slope. So if we look at the original and count the slope, it looks like it's going up one right here. So we can change that slope to be 1/2, and then move this until it goes through that point, which should have been at 2. So the equation you were looking for was y equals 1/2 x plus 2. Questions on that one? You really can't do in decimals because it's solving for x. If it said solve for y, then you could. So because we're solving for x, get rid of the y term. And then divide both sides by 2. Because neither of these can be simplified, you can leave it all as one thing. So that should have been your equation for number 5. 10 minus 5y all over 3. Yes? You won't see it like this, since these are the same denominator and neither is simplified. Go watch it as 1. So technically right, but you won't see it like that. Okay. Other questions on this? Yes, Alex. Is it? It would be the same thing either way. Okay, go ahead and close your laptops. You no longer need them. And you should have these notes in front of you. So today's lesson is solving. There are multiple ways to solve quadratics, but this is just one of them. Solving it using factoring. Matthew, close your laptop. All the way. Put it away. Thank you. So if you don't remember how to factor, you may want to take out your factoring notes, the different ones, so that you have a refresher, a reminder. You may have time to do 1 or 2 of these. So step 1 for all of these problems, make sure your equation is set equal to 0. If it's not, get it there. Factor whichever side is factorable. It doesn't matter if it's left or right. And then once you have factored it, set the factors at the end equal to 0 and solve. And then we'll write our answer in brackets. Okay. This one is a trinomial where there's a 1 in front. Anyone remember the rule on how do we factor this type of trinomial? Neither? So find 2 numbers that multiply to be 3 but add to be 4. And 1 would work. In this type of trinomial, if this is a 1 in front, you can write whatever your factors are from here. Whatever the variable is, put that first in both. we have to put equal 0 because we actually are about to solve for it. Before we did not because we were just factoring. So now you're going to set each factor without the parentheses equal to 0. And you're going to solve both of them. Once you have your two answers, you're going to put them in curly brackets, least to greatest. And that is how we solve by factoring, solve quadratics by factoring. What questions do we have on that one? Once you have that written down, we're going to go down and do number 10. We're just going to skip around on this. Number 10 has two terms, a binomial. There are only two ways to factor a binomial: difference of squares or GCF. Which one could we use for that? GCF. What is the GCF here? 3x. What would be left if we divided that out of both? X plus 5. This is now factored, so we're going to take both factors. The 3x is considered 1, and the x plus 5. As you start to get the hang of this, anytime you have an x term, a number in the x term, this will always be 0, so you don't have to show this word, but you can if you like. And once you get used to doing this enough, this will always be the opposite. So you don't have to show that work, but again, you can. Once we get to more complex ones, you will have to show the work for that one. So those would be your zeros, your solutions for that one. And we'll stop there. Do we have any questions about 10? And are there any others on this page we want to see you go over before we move on? Thank you. 7. So find two numbers that multiply to be 25 and add to be 10. Positive 5, positive 5. You have x plus 5, x plus 5. Since they are the exact same thing, you only need to set one of them equal to 0. And solve. And when you get your answer, it's going to be the same thing for both of these, so you would only write it once. What would that solution be? So if you get something like that, you would only put it once, not twice. Other questions on this page? If not, move on to the next. We're going to do number 13. So again, this has two. It's a binomial. Can we use GCF or difference of squares here? And if so, which one? Someone said it. Which one would be used for this one? Difference of squares. Remember how to do the difference of squares. think about what times what would give you x squared. What would that be? X. So in your parentheses, x would come first. What times what would give us 64? And then you put a plus and a minus in one of them. So set each one equal to 0. And solve them both. What would your solutions be? So you can write it as plus and minus 8, or as them separately. Either or. What questions do we have on that? When you put it in the quadratic, yes. Yes, we could do 11. So for 11, would we use GCF or difference of squares first? GCF. What is the GCF? 6x. What would be left when we divide that out? X minus 2. Set both factors equal to 0. What would your two zeros or solutions be? 2 is one of them. What's the other? 0. Any others in 12 through 16 we want to see, do, or go over? If not, jump down to 20. What's different about this one? Okay, there's stuff on both sides. It's not equal to 0. So we have to get it equal to 0. The easiest way would be whatever makes this positive. So move this over because that would keep it positive. So that way this becomes x squared minus 14x plus 48. And then you would go on from there. So what two numbers multiply to be 48, but add to be negative 14? Add or subtract. Negative 6, negative 8, that would work. So set this x minus 6 and x minus 8. Then set both factors equal to 0. What are your two solutions? Have questions on that, or any questions in 17 through 24 we want to see, do, or go over? Really? 24. Okay. This one, again, wherever your x squared is, and it would be positive, move anything else over to it. This one doesn't have a constant, so when you subtract 9, you're just putting it next to it. norms, so GCF or difference of squares. Someone said it. What would the GCF be? Difference of squares. So then what would those two factors be if we use difference of squares? 4x and 3. So 4x plus 3 and 4x minus 3. Set both factors equal to 0. These ones, since they're not the simple x minus or x plus a number, actually solve them both. So you should get negative 3/4 and positive 3/4. Write it like this, or separate. Any others in that section we want to see you go over, have questions about? Okay, bye. Which one would we move over? The x. So that we have 4x squared minus 28x equals 0. How could we factor this? GCF. What would the GCF be? 4 and what would be left if we divided out 4x? Set both factors equal to 0. What would your two solutions be? Zero and positive 7. Go on to the next page. And now, for example 1, we have an example where the a value is no longer 1. What would be our first step? What do we have to look for first? What do you go through? Someone said something, but I didn't hear what you said. GCF. Does this have a GCF? Yes. What is it? 3. So if we divide 3 from everything, what's left? So then, looking at just the inside, this becomes what we were just doing. So finding two numbers that multiply to be negative 4, but add to be 3. would work. Nature. -1 and +4. Keep bringing down your 3. But in this case, when you go to set them equal, because if I set the 3 equal to 0, nothing would happen. That wouldn't be a true statement. I'm not going to do that part, just the factors themselves. And solve. What would the 2 zeros or solutions be? Questions on that one? It's part of the factored answer, but it's not part of your solutions. We have to put it as this part, but it's just not one of your answers. Now, if it had a variable out there, so like 3x, then we could have that. Okay, we're going to try one more example from this. Example 3. Does that one have a GCF? So then, anyone remember what we do next? What's the next step? Multiply what 2 again? So you multiply these 2 together, and then you're looking for 2 numbers that multiply to be -10 but add to be 3. What numbers work? But then we don't just write them into the factors as we have been. We rewrite it using the first and the last and those 2. Does not matter whether you put the -2 first or the 5 first in the middle. What's our next step? Split it down the middle. And after we split it down the middle, what do we look for? What do we do? Look for the GCF on both sides. So what would that be on the right, on the left? 2x. Leaving us with what? X. What would our GCF be on the right? 5. Leaving us with what? 1. Then we could rewrite those factors. 2x plus 5 and x minus 1. Set the 2 factors equal to 0 and solve. What are your 2 zeros or solutions? Are there any others we want to see on this page or any questions we have in general? Example 2 or number 2? Alright, so number 2, this is one have a GCF? Yes, what is it? 4. If you take 4 out of everything, what's left? Then the inside no longer has a number in front of x besides 1, so we're looking for 2 numbers that multiply to be -7 that add to be -6. What 2 numbers would work? I heard 1 and 7, but one of them was negative, but I didn't hear which one. -7, +1. The 4 doesn't have a variable, so just set the other two factors equal to 0 and solve. What are the 2 solutions we have? We're going to do one more of these type of examples and then we're going to switch gears. So go on to the next page. We're going to do number 14. What would be our first step? Okay, equal to 0 by doing what? We subtract everything from the right and move it back to the left. We get 4x squared plus 7x minus 2. Does this have a GCF? No. So then we're multiplying for -2, looking for 2 numbers that multiply to be -8 that add to be 7. -8 and +1, would that give us +7? Which one? -1, +8. Rewrite it into 4 terms, split it down the middle. What do the first 2 have in common? X. What would be left if we divided that out? 4x minus 1. What do the second 2 have in common? +2. And if we divided that out, what's left? 4x minus 1 again. So then we have x plus 2 and 4x minus 1. Set both factors equal to 0 and find your zeros. What are 2 solutions be? -2 and 1. Are there any others on this page we want to see, do go over before we move on? have a GCF. So then multiply 8 and 3. Find two numbers that add to be negative 10. Which numbers work? Say that again. -6 and -4 would work. So then split it down the middle and find your GCFs on both sides. What would the GCF be on this side? 2x. What would be left? What would the GCF be on the right side? -1. Leaving us with the same thing. We have 2x minus 1 and 4x minus 3. Set them both equal to 0 and solve and find your solutions. Should have gotten 1/2 and 3/4. Do we have any questions on how to solve quadratics by factoring? The hardest part is knowing how to factor. What method are you using? Go on to the next page. And I'm going to have you write this down. Draw these in also. We talked about different names for roots, solutions, x-intercepts before. We talked about this is where it crosses the x-axis. Now it's just more specific, where the parabola, the U shape, crosses the x-axis. You have 3 different types of solutions. 2 where it crosses the x-axis twice. 1 where it touches the x-axis only once. Or none where it does not touch it or cross it at all. Once you have all of that written down, example 1 or number 1 put that into your y equals on your calculator. Yes. Put number 1 in the calculator in y equals. After you have that in your y equals, go into your table, second graph. And we're going to look for where your y values repeat. So you might be able to see it depending on what your table's on. You may have to scroll up or down. So here I see 16, 7, 0. They keep repeating. Find the middle where it stops repeating. What is the middle? -2, -9. So you're going to put that in the middle of your table. Second graph. And then you're going to use your calculator table to fill in the rest of the values. -8, -5, 0. Because it's symmetric on both sides, I can take these and rewrite them. Graph all of those points. And make your U shape from them. Once you have it all graphed, how many solutions do we have? 2, 1, or none? 2. And what are they? We're going to write them as ordered pairs. So usually when you're finding roots or zeros or solutions, x-intercepts from a graph, you'll write them as intercepts, but sometimes it'll want you to write it how we were just writing it, in curly brackets. So be on the lookout. If it says write them as, intercepts, write it like that. If it doesn't, you can pick either or. If it says write it using curly brackets, then write it like that. Any questions on how to find the number of and what the solutions are from a graph? We are going to do one more example, but before that, I want to show you something on your calculator. You could also find it on your actual graph. If it looks like it goes through 2 points, those are most likely your solutions. If they're whole numbers and you want to double check that they're whole numbers, you can go back, look at the the table, make sure that they match. If you don't see them on the table, you could do this, and we've done this before. Second trace, find your 0. You can only do one at a time, so let's say I'm looking for this one. I want to make sure it's at -5. Pick some number to the left, doesn't matter what. Pick some number to the right that doesn't go past the second one, and hit enter, and it should tell you what that is. If you are using Desmos, just put in the equation and all of those points will pop up. Put in example 3 and y equals. Go into your table and start to find the middle. You may have to scroll up or down. Where's the middle? 1, -2. So make that the middle of your table. And fill out the rest. And then once you have your points, plot them. You don't have to plot the ones with -11, but you can if you so choose. How many solutions does this have? Does it cross the x-axis? So none. You can put none, NA, the 0 with a line through it. What we cannot put is 0, because that would mean there's one at 0. We don't want that. So any of those. Do you have any questions on how to graph it, how to find the zeros from a graph? And are there any others we want to see, do or go over numbers 2 through 6 on the back? Camera. So put that in your y equals. Find the table, find where the points repeat and they don't, find the 6. Where's the middle? sure you're not graphing. So only graph what you can. How many solutions do we have? How many times does this cross the diagram? Twice. What are the two? There's a line for it way up here. I'm going to just write it here. 0 and 0. No, 2. You can write that on the line or write it in here, doesn't matter. Ignore this bottom part. We're not doing that. Go on to the next page. This will be the last thing we do today, and then you have time to practice. So the last thing is kind of going backwards, writing the equation from the roots or solutions. So if you know what your solutions are, you could write your equation. I know the numbers are a little small, but find where it crosses the x-axis. And it should be at 2 and -4. So it has two solutions. Then you're going to write those two solutions in factor form. So this is like the opposite of what we did before when we were factoring. The factor form of -4 would be x plus 4, and the factor form of the 2 would be x minus 2. It's always the opposite. If you're not sure, you could take what you put, set it equal to 0, and solve, and make sure you get the correct 0. If you don't, you know the symbol was switched. Then to write the equation, we're going to distribute. X times x gives us what? X squared. Then we have -2x, positive 4x, -8. And then we could combine our terms. So if I were to graph this and this, they would overlap on top of this. So as long as you know your zeros, you can find your equation and vice versa. What questions do we have on that before we do one more? What are your solutions or zeros for 2? 7 and 8. So what would the factored form of those two be? Victoria, you could say 1, Kim, you could say the other. X -7, Kim, and then move forward, distribute. So x squared -8x -7x plus 56. Or x squared minus 15x plus 56. Do we have any questions at all on how to find solutions from a graph, how to write the equation from your solutions, factoring to solve? For remainder of class. So first, if you did not finish in your test nav packet numbers 1 through 14, finish that first. Then do 15 through 21, so the next 7. After you've done that, you could be working on Khan Academy from last week or this week. You can keep working in the SOL packet because the rest are due on Friday. Or you can keep working in test nav. But test nav first, use Desmos. Try to use Desmos on as many as possible. Then you can be working on other things.